Hello everyone, I am Suchita Morir. Welcome you all in the video lecture on the topic numerical methods, method of false position, that means Regula Falsi. We can apply this method for solving algebraic as well as transcendental equation for finding the real root. Now what is meant by algebraic and transcendental equations? Now algebraic equations of nth order has the form f of x equal to a naught plus a1x plus a2x square up to an x to the power n. Now here a naught, a1, a2 up to n, which are the constant values. Here first condition is f of x equal to 0 has exactly n number of roots, may be real or complex. Second, if f of x is exactly divisible by x minus of a, then x equal to a is a root of f of x. That means f of a equal to 0. Now third condition, if f of a and f of b have opposite sign, then f of x equal to 0 has at least one root lying between a and b. That means f of a and f of b have opposite quadrants. It crosses the x-axis whenever its value equal to f of x equal to 0. That means at least one root lies between a and b. Now, algebraic equation in this equation number 1 form. Now, transcendental equation, that means non-algebraic equations are called transcendental equations. That means in short, these equations contain e to the power x term, trigonometry term, log term, then we call these as transcendental equations. For example, these are the equation first containing cos x term, second equation containing e to the power x term, and third equation containing log x term to the base 10. Therefore, we call these as transcendental equations. Now, by using this method, we can solve or we can find out the real root of these algebraic as well as transcendental equation. This is the application of this method. Regula Falsi method. Now in this method, first step is we choose 2 points x0 and x1 such that f of x0 and f of x1 are of opposite signs. And then we apply the formula of this Regula Falsi method. This is the important formula, that means equation number A. Now here we consider f of x0 and f of x1 are of opposite sign if this value f of x0 is positive and f of x1 is negative, for example. Then by using this formula, substitute here values x0 f of x1 minus f of x0 x1 upon f of x1 minus f of x0. We have to choose these x0 and x1, and accordingly we have to find out f of x0 and f of x1. Now after that we get the value of x2. Then we find out f of x2. If this value is negative, then we consider previous value as positive value. Then if f of x2 and f of x0 are of opposite sign, because this x2 is negative and f of x0 is positive, the roots lies between x0 and x2. We replace x1 by x2 in the equation A and obtain the next approximation, that means x3 value. The procedure is repeated till the root is obtained to desired accuracy. In this way, we apply the formula and we take the values positive f of x naught and x1 values are positive and negative are of opposite signs, and then find out the roots. We minimize the error and find out the accurate value by number of iterations. Okay. Now we discuss here one problem. Example number 1. Find an approximate value of the root of the equation. This is the algebraic equation near x equal to 1 using method of false position. Now here consider first step f of x equal to this gives equation number 1. Now we choose two values of x such that for one value f of x is positive, for another value f of x is negative. Now if we consider f of 0, its value is minus 1. Now f of 1, its value is 1. Now zero point 0.5, its value equal to minus of this. That means here we can consider x not equal to 0, x1 equal to 1, or we can consider x not equal to zero point 0.5 and x1 equal to 1. We can take any two values, means positive negative values, that means combination of these two or these two. Here we can take any positive value and one negative value of f of x naught and f of x1. The last answer will be same. The number of iteration will be depend upon these values. Okay, if we consider f of zero point 0.5, that means its value is minus 0.4375, which is closer to 1. Therefore number of iterations are less when if we consider zero point 0.5 and 1, and if we consider 0 and 1, then number of iterations are greater. Only this is the difference, otherwise we will get the same answer. Now in this problem we consider here x not equal to zero point 0.5 and x1 equal to 1. Roots are lies between zero point 0.5 and 1. Therefore x not equal to zero point 0.5, x1 equal to 1, f of x naught and f of x1, these values, we substitute these values in the equation A and simplify this, we get 0.652. Now if we get in the we find out each and every value up to 4 decimal place. If there is change in the last decimal place, then plus minus 1 difference is okay. Then x2 equal to this value, f of x2 is negative, therefore we find out f of x1 means this value is positive value. The root lies between 0.6521 and 1. Now in first iteration the root lies between zero point 0.5 and 1. Now the range is reduced. The root lies between 0.6521 and 1. Now in next value, here we have to find out x not equal to, we consider 0.6521, x1 equal to 1. Again apply the formula A and find out the value of x3. x3 is 0.7019, and we find out the value of f of x3. Its value is minus 0.0553. Now this value is negative, therefore again we consider f of x1 as f of 1, and the root lies between 0.7019 and 1. In this way the range is reduced and we minimize the error, find out the exact answer. Now apply in third iteration, apply same formula and find out x4 values. Continue this process till the difference between two consecutive values of x, that means x3 and x4, if this difference is less than 0.0005, then we stop the iteration, or f of x value equal is approximately equal to 0. Now x4 value equal to this 0.7175. Again we find out these values. F of x4, this value is near to 0, then find out x5, then x6, continue this process. Now here this value is minus 0.0017, that means approximately equal to 0. And in fifth iteration we get the value 0.7243 and here 0.7238. The difference between these two values is less than or equal to 0.0005. Therefore we stop the iteration and we write down these values in the table. Here in table iteration, number of iterations, x naught, x1, f of x naught, f of x1, x2 by using formula, and f of x2. We substitute all these values and here we observe the difference between these two values is less than 0.0005. Therefore this is the required result and its f of x value equal to 0.00 minus 0.0002, that means this is approximately equal to 0. Therefore, our answer is real root is x equal to 0.7243. In this way, we apply this method for transcendental equation also. Only the difference is that main point in the solving transcendental equation as uh, we use the calculator in radian mode and then find out all the values. And these are the practice problems which contain transcendental as well as algebraic equations. So, thank you.